Hi everyone, I'm Angus. I'm a solutions architect working in TrueWatch, and today I'm going to be talking to you about observability's best practices. So just a quick question for everyone. Whenever your application slows down or fails, how long does it take your team to find out the real cause? So if you're digital first, reliability isn't just a IT detail anymore. It's actually revenue, trust, and risk management. So in this presentation, I'll be explaining to you why observability has become board level. So this is what you'll learn today. 3 things kept very simple. 1. Why observability is now urgent. Number 2. What good looks like. So you can see the outcomes and KPI that executive actually cares about. 3. How do you actually fast an observability program? By using a 4-phase pilot that you can run and scale. So let's now look at the forces pushing observability from optional to essential. So it's important to know the 4 forces that are making observability non-optional these days. So across industry, these are the 4. Firstly, AI adoption. As AI features spreads, systems become more connected. There are more services, more APIs, and also more things that can fail. So it's not enough to just see problems. We need to be able to explain them end-to-end across the stack. Second, supply chain risk. Right, so third-party services and open source libraries expand the blast radius. A change outside your company can actually trigger an incident inside a critical customer's journey, but yet you are still on the hook to find the cause fast. Data residency. So data rules are getting stricter, and that pushes systems into multiple regions and environments, each with different controls. The question then becomes, can we observe what's happening without breaking governance and compliance? Fourth, cloud spend control. So more leaders are asking these days, why is the cloud bill so hard to predict? That's not just about purchasing. It's actually about the engineering control. What we collect, how much we keep, how we sample, and also how do we manage high cardinality data. So with all this you put together, complexity actually goes up while tolerance for downtime and wasted spend goes down. So then the next question is, why does this matter financially?
Incidents are no longer purely technical events. They are also economic events. When a critical journey fails, example, login, checkout, payments, and onboarding, every minute matters. Even when the root cause is small, the business impact compounds fast. So the question leaders should be asking is, do we have monitoring? When something breaks, how quickly can we restore service? How confidently can we prevent it from happening again? So as you can see from the diagram here, full stack observability is the mechanism that reduces both downtime duration and also business impact. So what we can do is to shorten the path from impact to evidence to action. From here, let's take a look at the benchmark behind the idea so that the economics are tangible.
The chart here on the left is actually a very useful industry benchmark. Organizations reporting full stack observability generally sees lower annual downtime of 70 hours versus those without at 338 hours. There's a huge difference of 268 hours, which is roughly 11 days of availability regained over a year. On the right here is the executive translation. So as you can see, less revenue leakage during peak periods means more engineering capacity because you spend less time in war rooms and fewer churn drivers because you reduce severe incidents. So the ROI is very simple. Savings is approximately downtime hours avoided multiplied by your dollar per hour impact. So in this benchmark, you can see that 268 hours times your business impact per hour, plug in your own number, and then you can quickly see whether the investment is obvious or not. Then again, most organizations then discover the real blocker isn't a lack of data, it's actually fragmented context across tools. So over time, many organizations accumulate tools. APM here, logs there, RAM somewhere else, plus separate alerting and incident systems. Each tool is definitely reasonable on its own, but then the combined effect is just brutal because context breaks. In an incident, team wastes so much time answering basic questions such as which dashboard is correct, which timestamp is the source of truth, is this customer impact or noise? Which deployment actually caused it? So that's why consolidation is not just cosmetic, it's actually strategic. What slows down resolution is not a lack of data, but it's actually the lack of shared context across teams and signals. So to make this concrete, we actually need to know how to separate a common misconception, which is basically monitoring is not the same as observability. Monitoring tells you something changed. Observability explains what changed, why, and what to do next. So through this table, you'll be able to tell the differences between monitoring and observability in terms of its focus, signals, and outcome. So monitoring focuses on known failure modes by using predefined thresholds and health checks, whereas observability explains the unknown unknowns via correlations and also answering new questions with evidence. Monitoring primarily uses signals such as metrics and alerts, whereas observability uses correlated telemetry and context such as logs, metrics, traces, events, and even user and business signals. So the difference in the outcome is basically monitoring just helps to detect and notify, whereas observability actually helps you to diagnose cause, reduce MTTR, and also prevent repeated incidents via learning. It's also important to know that in distributed systems, detection is rarely the hard part. Correlation is, which is why in observability, it's very important to connect user symptoms to backend traces to logs and changes across teams, services, and environments. This is super important because executives don't fund dashboards. They fund explainability, which means fast truth during high-stake moments. So now that we understand what's the key differences between observability and monitoring, then we'll be able to understand why the investment conversation often comes about talking about outcome and not tools. Executive funds observability for outcomes, not dashboards. But how do we actually quantify and measure this? We measure it using these 4 factors. Firstly, reliability. What we want to have is lesser MTTD and MTTR, and also lesser severity 1 incidents. Second, customer experience. We basically want to have higher conversion and NPS and also lower churn risk. And we measure it by using journey latency, front-end error rates, and also abandonment signals. Cost predictability. We want to have lower bill shock and also increase of unit economics. So how do we do this? We make sure that there are fewer spend surprises and better cost to serve efficiency, which is often measured via telemetry spend trends and also top talkers. Fourth, risk and compliance. We basically want to increase the auditability and also reduce data leakage. And how can we actually measure this? We can measure this by using the telemetry redacted, assess exception, and also audit evidences. So now let's translate outcomes into an operating loop and see how TrueWatch turns telemetry into decisions. Right, so if there's one mental model to remember, it's this. Observability isn't a dashboard project, it's actually a decision loop. So TrueWatch is built around 3 verbs: collect, correlate, and act. Collect basically means making telemetry trustworthy and global. Instrument and ingest the right signals, normalize and tag so that teams share the same language, and control cost and access from day one. Correlate. Correlate is where the why lives. So we unify context across signals so that everyone can see the same incident story, detect what matters using SR open and anomaly signals. Then we explain issues with guided diagnosis and also change context. Last but not least, act. Act is what turns insight into business value. So we alert and route correctly with ownership and runbooks, automate response where it's safe, and also loop and also close the loop so incidents don't repeat. So then the next question would be, right, how do we prove this, and how do we prove this really quickly without boiling the ocean? This is a 4-phase pilot program that actually proves value. The principle is simple. Don't self-transformation first, self-proof first. So in order to self-proof, we have specifically deliberately scoped this to just one app, one critical user journey, and one incident workflow. Because in observability, the biggest risk isn't about the technology, it's about the adoption. And team will only adopt it and also change how they operate only when they see an end-to-end win. So in this case, one journey done end-to-end beats 50% coverage everywhere. So going into the phase pilot, for phase 1, what we want to do is to connect sources, define tags, and role-based access control, and also baseline today's KPI. Phase 2, instrument 1 to 2 critical journeys and also connect the chain from RAM, APM, and logs. Phase 3, define SRO, tune alerts, and also set routing plus runbooks so that the team can act consistently. Phase 4, have an executive readout to see what's improved and what's worth, and also to roll out a practical rollout plan. So once you complete this 4-phase pilot, you essentially have proof to push for full-stack observability adoption in your company. Right. Then from there on, the final step is just to scale. Observability is the control system for modern software. So in summary, to close, the goal isn't more data. It's about faster decisions with evidence. If you would like to learn more about observability and TrueWatch, check out our full YouTube playlist, schedule a demo with our team, or even try the hands-on GitHub demo. See you next time. Bye!